Okay, you're back live. Hello. Meetings take a lot out of me for some reason. I don't know. Kernel engineer's problem. But at least I'm just writing today. All right, let's get started on this. We got all this done. Let me just go warming up. Let's just go get all the links. Okay. Where's their paper? Crazy that they that like these publications still have like this restricted access bullshit. It's a very well named paper. They not have the PDF? Oh, here it is. Hey, Barath. Welcome. I am currently working on the reinforcement learning compendium of sorts. This is all material designed to help new people to the field. I don't do this type of stuff super often, but it's been heavily requested, so. Did I get 10? 1, 2, 3, 4, 10. Welcome, Potato. 2.3K words is crazy. This is half of what I've written so far for you guys. There's also, for my articles, there's the general intro guide, which is another 2K words. I don't want it to be excessively long. I want it to mostly be a reference to other things. But it's going to be quite complete. People have kind of like... The way I tell people to learn things, the thing is like, I'm pretty dang independent with the way that I approach new problems. And like, if you tell me exactly how to do something, I'm probably not going to do it that way anyways. And that works really well for some people. But like, a lot of people have just been asking me for basically a step-by-step, like, what do I do to learn RL? So that's what I'm trying to do here. Thanks for the effort. You got it, man. The support has been great lately. Today was awesome. Like, look at this. We got plus 600 followers today. We're gonna hit 10K soon. 10K is a huge account in reinforcement learning. That's like been a long time goal of mine. Like most of the people that have accounts that size in RL, they also post politics or memes or some other things. It's actually like pretty hard to get to a sizable account when you're just posting deeply technical content. If you notice, right? Like pretty much everyone else I can think of in RL who has a larger account posts other crap. I allow myself like one fitness post once in a while because I've actually gotten a couple of people to like start actually getting in shape, which is very important, but it's very rare. Okay, this is a good reference. Started streaming too after seeing yours. Welcome. I've had fun with it. Hi, Joseph. Watch your live stream every day when you were working with Scython. Every day a few months ago, and then I got busy with stuff. Felt like it would be good at least have a summarization each of your live videos. Maybe in the description. Oh man, it's like, it's kind of tough to do that is the thing, because you see this on YouTube, right? But it also goes to Twitch and X. I guess technically the main VODs are on just YouTube, yeah. There isn't really a topic is the thing. Like, most of the streams don't have a coherent topic for the most part, the most spot. Trying to think if there's a way that I can do that easily. I'm actually kind of surprised that YouTube hasn't added a thing for that, because they already get transcriptions, don't they? Trying to think what to do with that. I mean, do you have any idea on how to actually do that other than, like... It feels like something that you should be able to do automatically. Not your videos. Treasure. Oh wait, was about to build a tool with Whisper. I missed one message. Make use of an element, summarize, put descriptions. Is there a way to do that through YouTube? We have over 1K subs. Is there a way to do that? This is not it. I missed several messages. Yeah, hang on. Let me scroll back through. It's kind of hard to set up like an LLM to do that thing locally because it's a lot of data. API to get the captions and do something with them. Do they have like a summary thing? No, it's all third-party crap. Because like if I have to like go download a 6-hour VOD and then feed a 6-hour VOD through a local model, right? I mean, if there is a third-party thing that I can just like add that will do it and not make a mess, I'll do it. We've made a lot of progress since the days of MOBA and Scython. It's literally a different field. Like RL is a different field from that, which was, I think I was doing that last summer. Don't feed the video, just the audio. Oh yeah, obviously. Is there an API that you can download? Can you just get the audio like that? Is that a thing you can do? Because if you have a thing that I can set up that I can do that easily, sure. Right, if I can just like have a model, even if I have to set up a container somewhere, if I just set it up on one of these machines, and I just like, you know, paste a link to the video or whatever, and it'll like just generate me a summary, that would be cool. that a question for me or Barath? That'd be a nice thing to have. I'll build one just for buffer. You can turn on a live caption button. Let me see. Let me see. This is the wrong tab. Hang on. So yeah. I actually have blocked links off. And it still blocks them anyways. There's no chat moderation. Oh, this is their... like, that's not it. Yeah, I don't know. If you have any idea where this thing is, or if there is actually a feature, I'll gladly, like, set it up. I'd also love to know how to set YouTube to low latency by default. There doesn't seem to be a way to do it in their UI. It's like you have to do it when you start the stream, but if you start the stream through Restream, it doesn't work. I feel like I was forgetting I didn't screw up a ball. Yeah. Oh, are there papers I can suggest people on applications? People always ask me about this anyways, so it would be good to just have these links. Let me just go grab all of the ones that I know. I think of other ones. Thorax. Simulator and Jax. Yeah, that's cool. I haven't looked at like the details of those specific apps to see if that makes sense as an approach or not. There are a bunch of other ones as well. I'm trying to think if there are any that are worth highlighting. They don't have like an article though. Yeah, it's YouTube. Okay. We'll do this. What did AlphaStar use to train? Wasn't it some crazy thing? It's the league play thing. But didn't they also have oh yeah, they also bootstrapped it with imitation learning. I forgot about that. What was the actual algorithm? Does anybody remember? Learning algorithm. Replayed experience, so it's off policy, yeah. So Himanshu. Welcome. Oh geez, it's already 4 p.m. How the heck did that happen? Like I've been lazy. Messages, meetings, and writing. They really have got to fix XDMs. Like, you should not be able to be getting added by this many spam bots. India, you're hardworking. It's Yeah, this is pretty lazy, I'd say, for me. We're not putting in crazy hours at the moment. Welcome, Rolo. Oh, Mark Towers is on here. What other off-policy papers do I give? What's the other one? Atari 200 times faster? What other off-policy papers? Impala? Maybe Impala. Lies. Lie. Here's the original world model paper. Yeah, this one. What are some good starting projects in RL? What would be an impressive project? Those are two different things, and it depends on your background. A good starter project, if you have a decent programming background, is something like a simple arcade game. Something that you can do within like a few days. You can see all the projects on puffer.ai. Many of these are made by contributors. Some of these end up being very useful in research where you would not expect. Like 2048 actually ends up being pretty good for research. Tetris, questionable whether it's as useful, but it's just freaking awesome to just watch. It's like really mesmerizing and cool to see. We've got like application stuff. Applications are always awesome. Things on different problems in industry, like this drone sim. So generally, newcomers to RL, pick something you can do in a few days. It could be applied, it could just be a game or whatever. And then what is an impressive project in RL? It's something that is going to pose a new type of challenge that allows us to test our algorithms in a different way, or something that unlocks a new application area for us. Those are the two things that are most impressive. DQN and PPO work on a lot of domains. What would the difference between my work be other than the env? So first of all, DQN doesn't really work on anything, unless you mean like the follow-up variants of it. PPO does work generally, it's just very fiddly. We're not actually doing either of those technically. We have a follow-up to PPO that is substantially more stable, a heck of a lot faster as well. So that's what we use for our training. We also do our own hyperparameter sweep work as well. What would my works be other than the M? So an environment can be a research contribution, right? If an environment allows us to study an algorithm in a way that we have not been able to before, or if it unlocks a new applied area, that is a major contribution. To give you a very quick idea of like one of the environments we used super heavily in development of 3.0, okay, so we have this grid environment here, and this can generate grids of like whatever size from this up to, the size of this full container. So they can be big, they can be small. And if you look at our release docs, we have agents that solve this thing relatively well just using the 0-1 signal of getting to the goal. So it's a very, very absurdly hard exploration task. And this served as a very reliable benchmark for us. And pretty much training on this environment was a very good indicator. Like doing better on this environment was a very, very strong indicator of doing better on everything. So this is like one example of a target designed environment for research. Applications are also useful, like the drone environment was one of the first super fast continuous environments that we had added. So continuous action spaces plus super fast, and allowed us to get some of the kinks out of continuous training. 2048 is kind of interesting because it takes a pretty dang long time to train, more than you would expect for something this simple. So it's like a non-trivial benchmark. There are lots of different things here. If you want to contribute to the research side, you can also do that. Do people create environments to test agents against each other, sort of like Kaggle? Yes, they do. There have been competitions like this. I have run several of these at conferences. I have colleagues who have run these at conferences. It is an incredible, mind-numbing amount of work, and it is not fun at all. So I don't do those anymore. It is absolutely something that can be done in principle, and knowing what I know now, I could probably do it a lot easier than I did it back then. But let's just say it was a traumatic amount of work. It was kind of just awful for everyone involved. Why 2048 took a long time? No idea. To be fair, I got the train time I got it from 6 billion steps down to 600 million steps with a very good hyperparam sweep. But 600 million is still quite a lot of experience for something like that environment. It's going to be a useful benchmark environment for us, though, because of this, right? Like, that's actually going to make it a useful benchmark. Even Expectamax works there. Min-max with probabilities. Well, yeah, you can do that, right? Like, if you write down any environment as an actual tabular game, right, versus having to learn everything from representations, it's going to be a lot easier. The tabular algorithms break immediately when you can't do that, though, right? Like, sure, technically you can say the same thing about mazes, right? Oh, I can just implement breadth first search or depth first search. AlphaGo things work better than their MCTS with learned functions. So AlphaGo is, you make the problem easier when you have the ability to set specific states, right? So yes, that should make it easier. Whether it's easier with something like mu0, where you have to learn the dynamics as well, that is less certain. I think in general, if we just if you look at the topics I'm writing down here, it's pretty much just a matter of going through everything that DeepMind has done over the last 7 years, ripping out all the fancy math that is there for the sake of them wanting to do fancy math, and figuring out what are the generalizable components that can be used to improve not just this crazy all we care about is sample efficiency thing, but balance sample efficiency and compute in a reasonable, sane manner, ideally with a tunable trade-off, then we'd be good. Nice teaching, thank you. I guess you could always bootstrap your RL learner with a search approach to speed up the initial few steps. It depends on what you're trying to do. Are you trying to make it train faster in wall clock or in steps? Because our thing is ridiculously fast in wall clock right now. It's possible we can still make it faster. Heck, I think we can probably double the speed just with even more infrastructure optimizations. Yeah, wall clock, we kind of steamroll everything already. We can train at 3 million steps per second. So everything's just fast in Puffer. We did 640 billion steps of neural MMO3, which is a petabyte of training data in 3 days and 8 hours on 6 GPUs. So our wall clock is very, very good. We're basically, what makes it so much faster? CUDA kernels? No, we really only have one custom CUDA kernel, which is the advantage function, which is we only had to do that because our thing is so fast. It's that we have environments that are fast themselves, so the envs are all in C, and they have our own infrastructure that doesn't slow them down. So we can do tens of gigabytes a second, no problem, from the environment side. And then we got really big batch training to work, and we cut out a lot of the overhead that people don't typically optimize because their trainers are too slow for it to matter anyways. CPU bound, everything in RL is typically CPU bound on the simulator side. And a lot of the GPU sims where they're oh, it's super fast, they're not actually that fast. So it's usually environment bound. A lot of stuff in reinforcement learning is environment bound. Or it may as well be environment bound because it'll be GPU bound, but only because you're using batch size 8 with tiny models. You're like, if you're using the GPU at 2% 2% efficiency, right, it may as well be environment bound because you're doing dumb things. Is RL easier to distribute because all you care about is rollouts? I would think that RL is kind of harder to distribute than everything else in general until you get into I guess the only thing that's harder to distribute than RL is the really big models where you have to do several dimension parallelism. But no, RL is really hard to distribute because you have a lot of data and you have to synchronize very frequently. We have it working though. You don't do the rollouts on CPU. You don't do the policy inference pass on CPU. That's the Impala architecture, and it's a shitty architecture. What if you share some of the states, you train several similar rollouts together, like you branch? Nobody does epsilon greedy things anymore, and that wouldn't matter anyways. Share. Okay, so our default training setup works like this. This is like the average training setup that we have. We take 8 CPU cores. On each CPU core, we simulate 1,000 copies of the environment. Or if it's a multi-agent environment, however many agents you need to get to a total of 1,000 agents. So they're like 8192 total agents. And then, in every single batch of data, every single rollout batch, we get 4096 agents worth of data. And while half of the CPUs are simulating data, you're stepping the other half of them. So the CPUs are always going in the background during the rollout process. Then you collect segments from all of those environments. So if you're going to collect 64 steps from each environment, that is a total batch size of 500,000-ish. And then we go over that 500,000 steps of experience with PPO plus our modifications using a mini batch size of somewhere between 16 and 32,000. And we usually just do one pass of it. That whole process collects us and trains on, well, for breakout, it's like 3 million steps per second. Most of the fast environments are 3 million steps per second. We have some larger policies, harder environments that we can get over 1 million, and then the really tough environments with bigger policies are going to be between 300 and 700,000 per GPU. And then multi-GPU, like Neural MMO 3, which is probably the hardest, we get 400,000 steps per second on one GPU. We get up to 2.2 million steps per second on 6 GPUs. Have people tried mixture of experts type things? Why would you do that? The policies are tiny. There's not really any reason to make like a larger number of tiny networks. Just computationally inefficient. Like the main problem with efficiency, right, in RL is that the like really small policies are hard to saturate because you get data transfer bound. No, it's not that it's CPU bound. Okay, it's that so really small networks are hard to saturate because you're spending more time moving data around than you are actually multiplying matrices because the matrices are not that big. So like it's pretty hard to get near optimal utilization or linear scaling, let's say, below like mid single digit million parameters. No, not because the batch size is tiny. Even if you give it a massive batch size, you still get bound. You still get like data transfer bound. Like you can do the math on what we should be able to be pushing here, right? Because like a 128 hidden dim LSTM should be 64 times faster than I believe it should be 64 times faster than a 1024 hidden dim LSTM. We can train a 1024 hidden dim at 1,000,000 steps per second. So based on that, we should be able to hit like 60 something million steps per second with a tiny LSTM, but you just never get that. I think that the most we've ever seen, we got something to hit like 15 million steps per second with gigantic batch sizes. You just get data transfer bound. We're not even necessarily data transfer bound. Like, it's not even just CPU to GPU. It can just be moving stuff into the like caches and spinning up kernels. You get overhead bound by all sorts of types of overhead. Well, we got this section done. I gotta write the infrastructure section and probably one more. Let me use the restroom real quick and I will be right back. Also, can I just say it's pretty dang nice, the growth today. Like, this is a ridiculous 9531 plus like 700 followers is awesome. All right, I'll be right back. Did you see the mega kernel for Llama? They only have one kernel for the entire Llama, so less overhead. Yeah, so that, I've been thinking of that for reinforcement learning, and it would be massively more important for RL than for everything else. You'd have to build something to gen the kernel, though, because, like, you need different types of networks. That would actually probably let you hit, like, if somebody wanted to do that in pufferlib, I would be all about it, because we could probably hit 50 million steps per second training. It would be insane. It actually wouldn't be anywhere near as hard, I don't think, either, because, like, the kernels are pretty simple. We have stuff that would basically work as kernels. They're kind of shitty. You'd have to actually get better matmls. Probably just matmls. Everything else is pretty easy. But, like, I wrote this. Let me show you. We actually used this on the website. So if you wondered how we got neural nets to run on your in your browser, it's this file. It's a tiny little file. 2/3 of it is just wrappers. So, like, it's easier for a UI. But, like, we have a linear layer, we've got a conv, we've got 3D conv, we've got an LSTM, we've got layer norm, embeddings, one hot. We've got, like, all the common operations in just brain dead simple C. Like, you could technically, like, what we do now is we wire these all together, and that's your network, right, for your forward pass. You could do this, add it backwards, convert it to CUDA, make a less stupid matmul that's actually tiled correctly and all that, and, like, maybe we get 50 million steps per second. I don't know. Mute. I don't know what that is. If you have an idea on how to do this, by all means, like, 50 million step per second training would be crazy cool. Cutlass. Heh. If you have an idea on how to do this, like, awesome. Why specifically in RL is it important? Because the models are smaller, and when the models are smaller, the overhead matters more. Because they run faster, so smaller chunks of overhead matter more. That's why. Most of the stuff is bandwidth bound. It's not specifically device-device bandwidth, though that is sometimes a factor. I think it's more so that you're just, like... to be fair, I don't really know. It could be kernel launch overhead. It could technically be just like it shouldn't be GPU bandwidth. Like it shouldn't be memory moving around in the GPU because that's really fast. But for all I know, it's just done incredibly inefficiently right now. Replay doesn't matter because so all of our data gets like we don't take the data off the GPU anyways. Once it goes on the GPU, it stays on the GPU. Like the entire PPO batch just fits on the GPU, and we don't come close to running out of memory ever. It's just fine. Why do you think LM people are using chain of thought and not any of the classic deep RL approaches? They are doing RL now. No, LLM people are straight up doing RL now. Have you seen Ken Stanley's newest paper on fractured entangled representations? So I have a friend and a colleague at MIT who worked on that paper with him. He does good work. I haven't had a chance to read the fractured entangled representations paper yet, though. So I cannot comment yet. URL, but it's completely different from the policy network. They use a lot of tokens. I mean, actually, they use no data at all compared to what we do in RL. Like we do training runs 20 times the data size of the pre-training of GPT-4, and we do it on one server. So by RL standards, they have no data. Differences. Oh, that's the test time compute thing, yeah. That's separate. That is separate. You can do reinforcement learning with or without test time compute. They're kind of separate. Where am I from? Originally Connecticut. Maybe RL environments are more type 1 thing. Type 2. Nope, depends completely on the environment. Depends completely on the environment. Some are one, some are the other, some are both. What are some cool applied domains that haven't been explored enough? So the one that I really want to look into, there are a few. So I think that the most practical one on the business side for us at the moment, and the one I'm spending the most time on, is drones. Lots of applications there. The one I'm more interested in longer term is like hardcore material simulation. I want to see if there's some way that we can do like molecule level or atomic level simulation, while cutting some corners and keeping it fast. Are you creating a company? Puffer AI is a company. So all of my stuff is free and open source. But we do have contracts with companies that want help with their reinforcement learning needs. We do like both basic service on Pufferlib and surrounding features. And we also do bigger things than that. What do you mean by material science? Where is RL involved? That's what we're trying to figure out, right? Most RL problems look like fiddly optimization problems. So I want to see if we can cast like materials discovery or testing or something as an interactive, basically as an interactive process with a sim. No cusp AI? Nope. Oh, cool. That's awesome. You have Yan LeCun on the board here. Funny. Is this a new thing? Oh, it's like pretty new. Oh, climate change? What are they doing climate change? Carbon capture and storage. Eh. There's so much more cool stuff you can do than that. Superconductors, like actually viable space, like space age materials. There are like so many freaking things. Yeah, superconductors would be the really obvious awesome one. RL for discovering a room temperature superconductor would be awesome. I don't know how that we could do that, but I'm trying to think if that would be the highest impact thing you could do or not. Would it be? Like, if you had to pick, like, one problem to solve to make the most sci-fi possible thing work. Would it be that? I don't know. Generally, I like things that make sci-fi tech real. That is what I like. Oh. Oh, perfect. Be $1 trillion+ company. Yeah, but like so is humanoid robotics, and that's like I don't find humanoid robotics particularly exciting at all. You know what actually in the robotics space I find way cooler than humanoid robotics? Like those industrial arms that are used in assembling stuff. I want to see those operating faster than you can visually track with your eyes. That would be cool. Just put a warning sign that's like, do not approach the robot with an icon of a blender on it. Robot at work. Do not approach. How many hours in Factorio, though? 0. That game does not appeal to me at all. I played Satisfactory for a little bit and then got bored. Yeah, that kind of nerd snipe does not work on me. It just doesn't work. The thing that really got me good for like a long time was optimizing MMO builds. That got me for a long time. But none of the manufacturing like logistics sims have. Welcome, Finn. Oh yeah, you were asking about applications. Finn is working on the drone stuff with us. Tried Path of Exile. Yeah, I never got into it. I don't really like that it's I don't really want a live service game of that style that's seasonal. I actually, the last few days, I've been playing Grim Dawn. I've been having more fun with that. I played Diablo 4 for a little bit and just didn't like it at all. Do you recommend doing a PhD? I only recommend doing a PhD to people who know that they want to do a PhD. Ultimate game for optimizing builds. Probably better if you don't get into it. The thing that I don't like about the build optimization stuff in those is that like they kind of are all boring to play. So it doesn't like you're kind of just optimizing a DPS number and like resistances and stuff. You're not really the stuff I was into. The MMO I played was basically it was fantasy chess on steroids. So like the number of interactions and the number of things you had to consider. Like you didn't have something as crazy as the passive tree and like socketing gems and all that stuff. But like there was a lot of complexity because the gameplay itself had a lot more complexity. Based on my experience, So, I had a very supportive advisor who let me do whatever. I was at what I would say is the best institution to do a PhD, and there's still just like lots of things that are not great. Academia is not the place to have fancy new ideas, as it turns out. Like, the place to do fancy new things is in like a financially comfortable, independent position, pretty much doing your own thing, like without any other strings attached. Academia does not like new ideas that do not fit the mold of how academia likes to see their new ideas play out. They do not like it when the solution to their problem is to rewrite all their garbage code and not do any like fancy new methods or write down any math. They don't like it when you force them to think about new problems that don't cleanly fit their math. Like, there are a lot of just bad, annoying things. Oh, and the paper writing process sucks. So there is a fair bit of overhead and a fair bit of constraint that you probably would not see from the outside. So that is the negative. Positive is, generally speaking, I still did have 5 years to explore the area of the problem that I wanted to explore, and I developed a lot of the core stuff that now makes it possible to build Pufferlib. So I would not have been able to build Pufferlib without doing my PhD. That is for sure. Who is Yaxine and what's he been up to? He is a tech guy who posts a lot of things on X. Like, he kind of just posts constantly, and he has a large following, and he does some quite cool tech stuff actually. But he's mostly just memes. So he was doing some RL and saw the drone stuff we were doing. I've been chatting with him. Been cool. Good VFS, VFX, and SFX. In a random loot, it becomes satisfying. Yeah, nothing beats gameplay loop, though. The most important thing for, games that you put a lot of time into is the gameplay loop. So for me, like, playing like an ARPG casually, like when I'm fried and I just don't want to think about anything, that's cool. But like, the games that I played, the games I sunk a ton of hours into, like one of them was old school RuneScape, and like, you wouldn't look at it from the outside, but it has probably the most satisfying mechanics of any game I've ever played at the high level. It's just like really good. There's got to at least be something, I think, there. Actually, the mechanic system of RuneScape was so good that it actually was the basis of a lot of what I did in Neural MMO, because it turns out it's also a perfect match for reinforcement learning. How does doing a PhD compare to working in a research position at big tech? If you can get a good research position at a top lab or company, you should do that. If you can, the thing is, usually you cannot get one of those without doing a PhD. It kind of depends, because like, a lot of the labs are not releasing enough stuff about their work these days. At least in like 2019 though, when they were actually writing blogs and stuff, I would say it was better. Welcome, Magider. What are the biggest advances in RL since PPO? Are the algorithms improving? Outside of Puffer, no. With Puffer, yes. We have the article right here on X. Puffing up PPO. This is our research. And this is what we released with 3.0 that makes everything work well. It is a generational leap in improvement. This did well. Missed a lot of things today. Yeah, working on the article. It's almost done. Probably be 3,500 words. Make Pufferlib standardized in academia. We do work with a couple labs. Academia is very stubborn about everything. I basically, if you want to think of it this way, I spent 5 years in my PhD trying to like sell my work to academics. And let's say I just don't do that anymore. I'm sick of it. Like, you're trying to help people who don't want to be helped for free. Make wall clock time competitions, they'll say it's invalid because it doesn't fit their holy grail of steps. Like, Nano GPT is not an academic thing. Like, you want to know what actually happened? Outside of robotics, almost all the RL labs just died. There are like 2 or 3 that actually kind of still do some things. And all the students now work on LLMs so that they can get jobs. So, academia succeeded in killing their field completely. You said you are a doctor and not a professor. Yes, a doctor is somebody who has a PhD. A professor works in a teaching position at a university. So, yeah. What is the content of the second part blog post? You're looking at it here. Tons of stuff. What made you give up? What do you mean, what made me give? Oh, on that? Academics not suited. Just a lot of the stuff that academia cares about, and like, they've kind of dug themselves into a hole in reinforcement learning, where like, the benchmarks that they've chosen have gotten slower and slower over the years. So like, they have no compute because they don't have budget for GPUs, and when they do have budget, they buy the wrong stuff, and then they manage it poorly, so it's even slower than it should be. And then they write like slow code, so it's 100 times slower than it should be. And then they take this like awful 100 to 1,000 times too slow code, and then they run it on a benchmark that's also 1,000 times too slow, and they just don't get anything done. Like it's a pure engineering failure. And the thing is, because they don't value engineering, even though it's completely preventing them from doing science, they don't care. How did you even get into MIT, my guy? I'm 17 and I want to apply there. Best of luck. At that age, all I can tell you is to work your ass off. There is not a single portion of my life where I have worked harder than in high school trying to get into undergrad initially. I did Stanford for undergrad, MIT for PhD. I worked, probably except for freshman year, I probably averaged 110 hours of work a week throughout high school. It was brutal. The most I've done after that for like even like a month or two is probably 90. And I don't work 90 now. Occasionally I'll work like an 80, 90 hour week, but I don't work like 90 hour a week months even. Like when I'm really focused and working on a new project, typically I will work a few consecutive 70 to 80 hour weeks building the thing, and then I burn myself out, and I work a few weeks of like 40 to 50 hours. Have you published first part of this blog? No, they'll probably go out at the same time. How much overhead in comms is there? Here, so it depends what layer you're talking about. Host to device can be anywhere from like 2% up to 50%. It's usually somewhere between 5 and 20% overhead. The scaling is not perfect on multi-GPU. We don't even need to do multi-GPU for most stuff because we solve it so fast. So we don't get perfect linear scaling there either. I think we get like 400-something thousand steps per second on a single 4090, and then we get like 2.2 million on 6 4090s. So we actually do have a little bit of additional CPU overhead in that configuration, so it's probably a little bit better than that. And then we haven't tried multi-GPU for environments that are like already 3 million steps per second. I'd imagine that wouldn't scale linearly. 110 hours a week is madness. Like, flexing so fast. Yeah, so basically what you're seeing here, right, is like, when you work a level of intensity for a while, like, even when I'm working at a very small fraction of that, it will look like, oh yeah, this guy's very focused. The thing is, it's just like, I've done way more than that, right? It's like the same thing where, like, I went and I ran my 50K and I hit my 1,000 total powerlifting. So it's like, people are always going to be like, oh yeah, that guy's relatively fit, even when I've been totally slacking for like months, right? That's honestly the best way. Like, if you want to be able to be that, like, a certain level of good, you have to just get way better than that for at least a short period of time that you can't even maintain. You can apparently get super linear scaling with multi-GPU. I don't think you can in reinforcement learning. I think that makes sense for large models where, yeah, you know what that is? That's got to be for large models where all the weights don't fit on one GPU, right? So if you have to keep loading the weights on and off device for each part of the model, right, it's going to be slower than if every GPU has like the same part of the model. That's just pipeline parallelism. It's not applicable to reinforcement learning. Our models are too small for that to matter. In general, scaling with multi-GPU. Yeah, so I mean, the thing I just described would be how you would do it, right? It wouldn't really work in RL. I think it's kind of trivial even. Like, pretty much you should get super linear scaling as soon as your weights don't fit on one GPU. Maybe even earlier because, you want to have ideally you don't want to have batch size 1. Need more examples for importable use case. Can do that. What was the hardest thing when you built Pufferlib? There's a lot of stuff. Like, in retrospect, each individual thing seems pretty simple, but like, simple doesn't mean easy. Honestly, a lot of it was just a perspective shift. Like, Pufferlib kind of takes every single thing in the field and flips it on its head. So, even if the final solution here is simple, it's like, it's such a radical departure from everything that's out there that like, figuring out how to do everything this way was just very difficult. Like, it went through many, many iterations, let's say. We went through many iterations. We started off just having these emulation wrappers that made it easier to work with complicated environments and improved a little bit of performance there. And then we did the vectorization thing that worked on top of that to get like up to 10x speed up, right? And then I started doing Python environments, and that very quickly got us to like 100x speed up, right? And then we improved our infrastructure. We went to C. We did like large batch stuff. We did algorithmic optimizations, PyTorch optimizations, and that got us to 1000x. And then now where we're sitting here, like, it's 1000x plus for a lot of stuff. How do you debug RL algorithms? Well, with Pufferlib, the fact is we have so many different environments, right, that we can get performance on a ton of different tasks. So when we introduce something that breaks something else, we can see pretty quickly. And when we introduce a change, we can see very quickly whether it just helps on one specific environment or whether it helps on like most of them. We also have environments that we trust more than others, where like if something does well on this, it tends to do well on everything else. Versus there are other ones where, if you just train something on breakout, it's usually better on breakout is better everywhere, but not always. It's not super generalizable. If you get it to work on mazes, it's usually good everywhere. If you get it to work on neural MMO3, it's usually good everywhere. How do you debug why an agent learned well or didn't learn well? You look at your data, observations, rewards, and then you watch the policy. It's almost always an error in observations and rewards, though. I have a debugging checklist on the docs page. Most difficult part stage of solving RL problems for beginner: lack of programming maturity. Just generally not being comfortable enough writing clean, simple, low-level code without breaking things. What are your favorite RL labs? What are some good ones to keep up with? There really aren't that many right now. Flare is Jacob Forrester's lab. They're doing good stuff. And then Eugene's lab has a few things. And NYU. I think Julian, I don't know if Julian's lab is still really doing much RL. They have a little bit. Let me think who else. I think there are still a few people at like Stanford and Berkeley who are doing RL stuff that's not robotics, but you don't hear about stuff very often. I mean, I guess we'll see if there are any new ones, like any new good things at RLC. Benjamin for Princeton? Eisenbach? I'm trying to remember. What are the latest things that he's done? Yeah. Oh, contrastive. I haven't really looked into contrastive at all for RL. I don't know if there's something there. Maybe. Cool, but not super practical. Yeah. You know George Hotz? Yeah, I bought the tiny boxes from him, right? Ended up chatting with him a whole bunch because we had a bunch of problems getting him to work initially, but they work quite well now. You think it is a good idea to make general purpose observation space converter? It's hard to do that fast. Very hard to do that fast. That is the big issue. You know, one of the things I was thinking that we could do, I don't know if it would work, but we could kind of just define the observation space to be like, I don't know, some upper bound. It could be like 256 or something. And then we could just put all the flat data from many of the different arcade ends into that and just see if we can train on, with padded observations and actions, see if we can just train on a bunch of different environments with the same policy. I think we could force it to work now. I honestly do. Super cool and doing amazing work. Thanks for the stream and open sourcing this. Thank you very much. I've learned a lot from RL from your articles and live stream. Faster than the knowledge I gain from books. Shoot out content and then I search and come across it. I'm working on it. This here is going to be like a 3,500 word article plus the other one. So 5,500 words of intro material with a ton of links. Let's try to this fixed bound, fixed length, unlength, general observation order. Bound, fixed length, unlength. So the thing with that, right, is I don't know if you'd have to do some experiments. Basically, I don't know if you can learn a useful shared representation. The data is formatted that way. It's technically possible that you could learn it in, like, you can't learn it in the first layer, that's for sure. It's possible you could learn it in later layers, but we use really shallow policies in reinforcement learning most of the time. Oh, 2.3K. Heck yeah. Okay. $5.44. I need to go in a couple of minutes here for dinner. We have a full draft of this. And where's the other one? Oh yeah, a full draft for this. So what is it usually? Is it 250 words a page usually? So I was aiming for about 20 pages of content. I ended up with like 21, 22 pages with the big heading, so it's probably 20 pages just about set on. How long was my quick start guide? It doesn't show you, that's annoying. Substantially shorter though. Maybe like 2K. I don't even have time to read through this once, I don't think, before dinner, so I think I will just call it. Anybody have any questions? Obviously, I also have to fix the doc section. the section of the docs on the webpage that I'm linking people to, or like add a little bit to that. I will do that. But otherwise, I think this is like a full draft. I'll edit this tomorrow. Actually, I have a flight to edit this on soon, so I'll probably just do that later this week. I don't want to spend too many days in a row writing, so we'll probably be back running experiments tomorrow. We will see. But other than that, yeah, thank you for tuning in, folks. Hopefully, you all enjoy this once it's ready. Puffer.ai for all the things. If you want to help me out for free, star the repo. Just star it. Really helps. The Puffer star. And other than that, you can join the Discord to get involved with development and follow me on X for more. We do the importable example today. Not really, because I gotta run for dinner. It is about to be 6 p.m. here. If you have general observation space is different from importable stuff. I don't know if I'm going to be working this evening. I'm not working crazy hours this the next little bit here. On night live stream. Yeah, I don't really know if I want to do another session tonight, to be honest with you. If you actually message me, though, I'll tell you what, though. If you actually message me in the Discord, because I wasn't going to do docs tomorrow, if you actually message me, like, specifically what needs to be done, I can do it on the stream tomorrow. Because you haven't told me what to do with the importable, like, what more to do with the importable example, or, like, what you're still confused about that it doesn't cover. So I'd like to improve it, but I need to know how. Okay, I gotta run, though.